Hi, Professor O'Donoghue here. Today we're going to talk about microcontrollers, and they are so important in our world these days because that's what makes equipment, electronics, phones smart. And we're all about smart gadgets and equipment these days. Okay, so first of all, you need to know that now we're about to delve into the discipline of computer engineering technology or computer engineering. So basically what computer engineering is a discipline that integrates electrical engineering, electronics, and computer science. Basically, what computer engineers are doing is embedding these little microcontrollers, these mini computers, into equipment, into appliances, making them smarter, into systems, making them smarter. So let's talk about, first of all, what we know. What is a computer? We all use computers, so we know what a computer is, right? Normally, it looks like this setup right here. Okay, there's a central processing unit, which is the brains of the computer, and normally it sits in this box on a motherboard. There is a keyboard or a mouse that a human uses to input information into the CPU. So this is called a peripheral input device. Then there is the monitor, which is a peripheral as well, but it's an output device. It is used for the human to be able to look at and see information from the CPU. So, humans are designed for humans. That's the whole purpose of the peripheral. So what's a microcontroller? Well, as I said before, there are many computers, but they're different in a computer in the sense that they are not meant to interact with humans. So they're little computers that we put into all types of machines, gadgets, and whatever to control them. So they're small, that's why they're called micro, and then they control the machines. That's the controller part. Here's an example of one of them. I think this goes into a robot. They're cool because you can build all kind of stuff with microcontrollers and make it smart. So that's why people like them a lot. Let's look at a couple that we are going to use. So right here I have two microcontrollers. The first one, and they're boards, so we call these boards because not only do they have the microcontroller IC, integrated circuit, which would be this right here. This is the IC. And basically what an IC, integrated circuit, is all the electronics that is used to create this microcontroller is in this package. And in this case, the package is called a DIP, dual inline pin package. It's in there. But it's a board because the board has other components on it in addition. So this is the brains of the board, and then you have other components. One of the things you have is a USB port because the microcontroller needs to be able to communicate with your computer, and it uses this USB cable in order to communicate with your computer. Okay, you have some LEDs on there that let you know some output information, and you have a power port on here for 5 volts power. You can power the Arduino with your computer by using a USB, or you could also just use a power supply. That's one. Then you have an 8051. We use this in our digital systems too, embedded programming class. Here is the 8051 IC right here, but this is the board once again, and the board has a lot of other things on it. It has some input switches, it has an output display. It communicates to your computer serially. So it has a serial port as opposed to a USB port. Okay, so there are hundreds, if not thousands, of different types of microcontrollers. Let's And like I said, they're so cool because they just let you make anything smart. And we love smart appliances and smart machines, and they let you control them. Okay. Some are programmed once, and that's it. They're just programmed once, and they're put in a specific application. For example, one that's used to control your microwave oven. Okay, that's all it does. It doesn't do anything else. You program it once, it's in there, and it does that. Then there are other reprogrammable microcontrollers like the Arduino that I showed you. You can put all different types of programs in that microcontroller to do a variety of tasks. You can reprogram it as many times as you want to. They're so versatile. They are used to control refrigerators, phones, irrigation systems, robots, your anti-lock braking systems in your car. I mean, just everything, all types of things. So they're very interesting to learn about, especially this Arduino, because it's what's called an open source microcontroller, which means that anyone can use it for any reason. There are no trademarks on it, and so even if you wanted to make a product and sell it, you could do so with the Arduino because it's an open source microcontroller. And if you go to the Arduino website, there's all kind of projects for you to download and play around with and just have fun with it. We already talked about what an integrated circuit was, but if you notice right here, this one is different from the DIP, dual inline pin package. This package is called a surface mount, and you'll see this on most, if you take out most electronic boards, you'll see these type of packages because they are much smaller than the DIP packages, and so you can get more on a board, and so they are used quite a bit in electronics. All right, so we're going to talk a little bit more about the Arduino. So I already told you that it was an open source, and basically what it's able to do is read inputs. That input could be a light on a sensor. It could be a finger touching a button that sends an electric signal. It could be a Twitter message. And what it does is take that input and turn it into an output that will control something. So maybe it's going to activate a motor, or maybe it's going to turn on an LED or publish something online. Okay, that's what it's going to do. What tells the Arduino what to do is a program, a computer program. And for Arduinos, that program is called a sketch. And so a sketch is uploaded to the microcontroller on the Arduino board. Okay? The Arduino programming language, which is called Arduino C, is very, very similar to just regular C programming. So if you know C programming, it'll be easy to program with Arduino C. There's also a software that you use to program the Arduino and to create the sketch, and it's called the Arduino IDE. And so we will talk about that a little bit more. Okay, so this is what a sketch looks like, and let me show you what the IDE looks like. So if I go and I click on my IDE, okay, this is what will happen. It'll open up a sketch, right? And so this is just a default sketch that was opened up when I clicked on my IDE icon, okay? So, but that's what it looks like. And so you can come in here and you can create this program, you can compile the program, then you can upload the program onto an Arduino. To get the IDE, you would go to www.arduino.cc and you'll get the latest version of the Arduino software. By the way, IDE stands for Integrated Design Environment. Okay. Now, what you have to understand is that the Arduino is a type of hardware, okay? And whenever you are trying to get your computer to communicate with any type of hardware, there are certain things that have to happen, even if, say, it's a printer that you have connected to your computer, right? So the first thing your computer needs to know is what is the device that you're using. So right now I have my Arduino, and it's an Uno plugged into the USB of my computer. If I look down here, you see it says an Arduino Uno. Okay, but if it didn't say that and I needed to let it know what kind of Arduino I was using, I would go to board and I would pick the proper board that I am using. Right, I would come down here and I would click Uno. That's what I'm using. All right, the other thing you need to know is sometimes you need drivers, just like you need printer drivers for your printer connected to your computer. You may need the drivers for the Arduino. So it just depends on your computer. And a lot of times, if you need that, you would go to Tools. Once again, on my laptop, it says Update Firmware. Sometimes, like at school, it'll say Update Driver or drivers, and you would go choose the driver that you needed for the Uno. The final thing you need to know is there is a communication port that your computer uses to communicate with the Arduino, and it needs to be on communication port 3 or higher. So right now, if you go to port and it shows the serial ports, we click 11. It's on port 11. You will see down here as well that it is port. It says communication port 11. Pretty hard to see, but it does. Okay, so this is your Arduino hardware. All right, after your hardware is set up, now you need to figure out how would you upload the program to your Arduino so that the Arduino could perform the task that you wanted it to perform. All right, so let's go back to the sketch. So here's our sketch. So what you would do is, first of all, let's see, say I want to use this built-in example of Blink. Okay, this is a program called Blink that's already created on Arduino. Okay, and it makes your LED turn on and off. All right, so I have my program right here. Luckily, I didn't have to create it. Someone else created it, and I'm just using a pre-written program. First of all, I would verify that the program doesn't have any errors in it. So I would click the check mark, and you'll see it's compiling. So I'm compiling my program. It's done compiling, so that means it's good to go. Once I'm done compiling, now I need to upload this program onto my hardware, onto my Arduino. So then I would click Upload. Once I'm done uploading, I see a message down here that says Done Uploading. All right, so then I know I am good to go. And so then what I'm good to go. So then what I should see is an LED blinking on and off my Arduino for 1 second. Okay, so if we switch over to our Arduino that I just uploaded this program onto, lo and behold, there's the LED, and it's blinking for a second. Let's count it. 1 1000, 1 1000, on and off for a second. Okay, so that's all about our microcontrollers. I'm going to create another another video specifically on the Arduino. But until then, have a great day.